Hi, let's do some calculus. Woo woo! Today's going to be a little bit different. I'm going to give you a few examples to work off of, and then I'm going to post my solutions to the other one so that you can see my work and also have a chance to practice. So this is just two more ways to integrate. It doesn't happen as commonly as some of the other ones, but I want to show you that it at least exists and expose you to this. So if you see a question like this, you can be like, oh yeah, I remember something about this. So let's do this. So there are some problems when you're integrating a fraction where the degree of the numerator is greater than or equal to the degree in the denominator. So if I were to take this and rewrite it, I wouldn't be exactly sure whether the numerator or the denominator was the one that was like the main part of the function. If I was trying to use u substitution, for instance, I wouldn't know what to set u equal to. So in this one, if I have x squared minus 4x plus 2 over x squared plus 2, another way that I could do this is because I can't take each one of these and divide it, and break up this fraction into something that I can take the antiderivative of, what I can do is use long division, so polynomial long division that you probably did algebra 2 maybe a little on pre-calculus too. So I'm going to take this fraction, x squared minus 4x plus 2, and I'm going to divide it by this quantity x squared plus 2. You can do synthetic division if you remember that, but I think polynomial is a little bit easier, or long division is a little bit easier to recall, so I'm going to do it that way. And I'm going to think, okay, what can I multiply by x squared plus 2 to get this, or at least close? Well, I'm really looking at only the first term, whatever this is. X squared times what gives me x squared, and I can say 1. 1 times x squared plus 2 would be x squared plus 2, or I would know this was plus 0x. That's why I'm writing it over here, because I didn't get any x's at all. And then I have to subtract this. X squared minus x squared, nothing. Here I would get negative 4x, and then 2 minus 2, I would get 0. So I've got negative 4x. This is my remainder because I can't think of anything that I would multiply x squared by to get negative 4x. So I'm going to say that this, I can rewrite it as this whole fraction is 1 plus my remainder was negative 4x. So I'd say whatever negative 4x divided by x squared plus 2 is. So I used long division to rewrite this integrand. Okay, now that I've got this, I can say, do I know how to find the antiderivative of this? Well, you could say the antiderivative of 1 was just x plus, and this is where you have to do some thinking and think, do I know what the antiderivative is of this? You could say, you could try to do u substitution in some way, but you could also just say, you know what, this is going to be x plus this integral negative 4x over x squared plus 2 dx, because you can break this into two separate integrals. This could have been the integral of 1 dx plus this. And then once you get here, if you want to use u substitution, you can. If you want to say, you know what, I think this thing, it's all raised to the negative first power. If I put it in the numerator, I could use pattern recognition to figure out what this is. You could do it that way too. But if I say, you know what, I'm not exactly sure, I'm not that good at pattern recognition, you could say u is equal to x squared plus 2. So then you'd have x plus this integral. In the denominator, you get u. If I solve for dx here, and do put this in terms of u, I would say the integral of dx. So I would say du dx, the derivative of u is du dx. And then I could say du is equal to 2x dx. If I multiply on both sides by dx, divide both sides. And instead of dx, I'm going to write du over 2x. And you might be saying, aren't you just substituting another x in here? But you see how I've still got this numerator of negative 4x? This is nice now because x and x cancel out. Negative 4 divided by negative 2 would be, or I'm sorry, positive 2 would be negative 2. So I've got x plus the integral 2 over u du. And then if I think about what is 2 over u, this would be the same as 2u to the negative first power. Add 1 to the exponent, I get 0, divide by 0. Something happens. When in doubt, natural log. You know, the common phrase. So I'm going to say x plus 2, because I can just carry coefficients along for the ride. I can even put it out front if I wanted to. This would be the natural log of u, and then I could be plus a constant. Okay, if I do a little bit more work, one more thing, because if I got an x over here, instead of u, I can write, we said u was x squared plus 2. Whew, so much work. But we did it. Okay, so what you're doing on every one of these is you're trying to figure out, okay, what about, like, what can I change this into using polynomial long division? So let me do one more on this page. How about this one, because it's a definite interval. So I'm going to go down to number 3. I'm going to say I've got this integral and I've got 0 to 1, so a definite integral. I need to figure this out. So I'm going to rewrite this from 0 to 1. And if I took x plus 1 as like the u in this, and then I tried to find du dx, I couldn't actually do it. It wouldn't get me to the point where I needed to simplify this. It wouldn't be helpful in any way. So what I'm going to do is take x squared. Oops, I almost wrote plus 1. This is just x squared divided by the quantity x plus 1. X times what would give me x squared? Sorry about this, just ignore that. This would be x times x. So x times x is x squared. X times 1 is x. You might be like, how do I subtract this whole quantity? What do I do? This would be the same as plus 0x. So now I can subtract. This will go away. 0 minus x would be negative x. And then this would be, actually, no, not even my remainder yet, because what could I multiply by this? I could say this would be by negative 1. 1 times x be negative x minus 1. I subtract this whole quantity. Negative x minus the negative x would be the same thing as negative x plus x, which would be 0. Negative negative 1 would be positive 1. 1 is my remainder. So if I rewrote this, I would have, this would be x minus 1 plus 1 over x plus 1, because I was trying to divide this by x plus 1. This whole thing dx. And now we say, could we find the antiderivative of this? The antiderivative of, because I'm trying to do the fundamental theorem of calculus, by the way, so I can do f of b minus f of x. So the antiderivative of x would be add 1 to the exponent, divide by my new exponent, 1/2 x squared. The antiderivative of negative 1, just be negative x. If I have x plus 1, I could rewrite this if I wanted somewhere as x plus 1 to the negative first power. If I add 1 to that, I get 0, divide by my new exponent. When in doubt, natural log. Natural log of x plus 1. And then this one, I don't actually have to put a plus c. That's the only difference in this, because I'm actually going to evaluate it from 0 to 1. So if I put in a 1 here, I would have 1/2. 1 squared would still be 1. Minus 1 plus the natural log of 2. This is all if I put in f of 1, so the function value 1, minus, and then I substitute in 0, I would get 1/2 times 0 squared minus 0 plus the natural log of 0 plus 1, which would just be the natural log of 1, which is 0. So all this minus 0. Simplify this just a little bit. 1/2 minus 1 is negative 1/2 plus the natural log of 2. Ta-da! Okay, there's 2 examples on that page. I'm going to show you one more type. So this was by long division. This is how we integrate. We're separating this. We're still just simplifying with the stuff inside, the integral symbol and the dx. So the integrand, the stuff on the inside, we're trying to turn it into something that we can take the antiderivative of. There's one more way to do this, and it's by a method you probably haven't seen in a while. And this is completing the square. And I have a note on here that you need to go back to page 98. So way back when. And actually on number 4, on that last one, you're also going to have to go way back and start looking at these things. So you're like, what's on page 98? Lucky for you, I've already gone back. This is where we did this, and it was like getting tricky with it, and we figured out why these things were the way they were. Remember, arc sine or inverse sine, we could say, is the same thing as sine of y is equal to x, and then we solved, and it was all good times. So way back when, so if you need a refresher, daily lessons 97 and 98, I think a long time ago, 100 pages ago, we found the derivatives of arc sine, arc cosine, arc tangent, and same thing, all the rest. Now we're going to use them. So in this one, it says complete the square. So let's do this. This is a little bit of a process, I'm going to warn you, but I'm going to do one of these and then one of these over here that you can see with this square root under, so you can see the difference between the two, because it gets a little tricky. In this one, I'm going to say, okay, I'm completing the square. So what I do is I'm rewriting this into something that I can find the antiderivative of. So I've got x squared plus 4x plus 8. This is not factorable at this time. So what I want to do is try to make it factorable. So I've got x squared plus 4x. And then I want to say, okay, well, what if I divided this by 2? I would get 2. Plus, or I'm sorry, divided it by 2 and then square it. I would get plus 4. So I added a plus 4 here. You don't actually have to put a line on it, but you're like, you can't just do that. But it is okay for me to add 0 to something. So I'm going to do that. So I added the plus 4 and the minus 4. Stay with me. So now I've got this integral of 1 over. This I'm going to rewrite as x squared plus 4x plus 4. I'm going to rewrite it as x plus 2. Quantity squared. 8 minus 4, I'm going to write as plus 4. And you might recognize right now that we've got something that looks like this. X plus 2 squared plus, over here I've got 2 squared, or I can say 4, but either way, this is going to be important in a second. This is squared. Okay, so I've done this much and you're like, why does this matter? Well, if we go back a really long time ago, on page 198, I can see that for arctangent, so the derivative of arctangent, I get u prime over 1 plus u squared. And for arccotangent, the derivative was negative u prime over 1 plus u squared. This 1 plus u squared is making me thinking, well, maybe I just have something like this, where it's the derivative of arctangent. And that's what's happening here. So I'm going to rewrite this, because in this one, do you see how it says 1 plus u squared? Oh, sorry, over here, 1 plus u squared. I'm not looking at this one because I don't have anything negative. 1 plus u squared. I need to somehow turn this into a 1. You might be thinking, how do I do that? So what I'm going to do is that I'm going to factor out a 4. So, or 2 squared. And I'm going to say, well, what if I take this divided by 2 squared and this divided by 2 squared? I would get 2 squared out in front. This, so divide this by 2 squared, that's what we're doing over here, and this by 2 squared. What would happen then, so I'm going way over here, still equal, I would get 1 over, out here, this 2 squared be 4, or I can keep it as 2 squared, doesn't matter. Then this thing I can write as x plus 2 squared over 2 squared. hard to see, but I'm going to keep going with it for a second, plus 1. And I'm just going to do one more fancy trick so you can see where I'm going with this. 1 over, see this 4 out here? This is the same thing as 1/4 times this whole quantity. I'm just going to bring it out in front. And then over here, I'm going to rewrite this as x plus 2 over 2. And because the numerator squared and the denominator squared, I can just square this, plus 1. I feel like this is a little bit of math magic to get it to that point. But you notice how now I've got something 1 plus u squared. So here I've got 1 plus a whole quantity squared. And then the only thing is that the numerator does not have, like this, if this was x plus 2 over 2, I could also write this part as 1/2 x plus 1 squared. So the only thing is, this numerator should be 1/2, and it's not. This numerator is actually, like, really, I've got a 1/4 out here. So I've got to think about, okay, what can I do to this instead? I could, let me redo this for a second. Okay, I'm just going to go over here because I know this is something like arctangent, so I might have to manipulate this in some way. But if I have this work, I've got tangent of this, of u, so I know it is 1/2 x plus 1 plus e. And I'm just going to check to make sure that I'm good on this. If I took the derivative of this right now, I would get this. So I would get 1 over x plus 2 over 2 squared, or I can say 1/2 x plus 1 squared plus 1. So just like this. And so instead of this 1/4 out here, I should have this. Sorry, I'm just checking to make sure that I'm right, that I'm good on this, because we should always match up with the thing, whatever's here over here. So in this one, I should have okay, cut this part out of the video. Hold on. Okay, so here's where we're at. So we've got this when I factored out a 4 and I'm putting this in front, and remember coefficients we can play around with a little bit more. So this isn't like our biggest concern, but I'm just going to bring out the 1/4 right here in front. And then I'm going to say, okay, so I've got this 1 over, and I can see it looks like what I want. I can see it looks like something, or u prime, maybe we'll get here, over 1 plus u squared. So you could do u substitution at this point and make the x plus 2 over 2 or 1/2 x plus 1 and put that in for u, but it will take a whole lot more work. So what I'm going to do is, knowing that I can play around and knowing whatever is here, to get to this, I would have to do an antiderivative, or this to go from here to here, I'd have to take the derivative. I'm going to try that now. And I'm going to say, okay, well, what if I just took the derivative as it stands right here, knowing that I can play around with this coefficient? Well, the derivative of tangent would be 1 over, and then I knew it's 1, or I'm sorry, the derivative of arctangent would be 1 over 1 plus u squared. So in this one, 1 plus 1/2 x plus 1 squared. And then I've got times the derivative of the stuff on the inside. So here I'm going to say times 1/2. And so I can see what's different about this one and over here is this one had a 1/4 and this one has a 1/2 in it. And so what I'm going to do, put the 1/2 here. Okay, so I use pattern recognition at the end, that I recognize that something's going on. You may use u substitution if you're like, I'm just not comfortable with this. And honestly, if you're feeling like, I don't know if I can do this one, keep trying it. I'm going to show you one more with the square roots in here because it will either be arcsine or arc cosine. These are the most common that you would see on the AP exam. I'd be really surprised if you saw these, but maybe, don't quote me on that. But we're going to focus on these ones. I'm going to show you one more of how to get that because it's a little bit tricky with the whatever the coefficient is. Okay, so let's try this one. So I'm on number 2. I'm going to flip to my example here. And I'm going to say, this one looks real gross, but let's go for it. I've got this integral from -3 to 1. -1, I'm sorry. And I'm going to rewrite this using completing the square. So in the denominator, I'm going to do the same thing as before. I'm just going to do it under the square root. So I'm still going to rewrite this as -x squared minus 6x. Oh, I'm putting this 7 out here, plus 7 on this side, just because it makes it a little bit easier for me. You do not have to do this if you're really good about thinking about negatives. I'm actually going to factor a negative out here also, just to make it a little bit easier on me. Oh, dx. And then I would have negative x squared plus 6x. So what I'm going to do is I'm going to divide by 2 and get 3, square it to get 9. And then I would still have this, did I even do this at the end? -7 at the end. And now once I do that, I'm going to go back just so I didn't mess with the negatives. And you're like, wait a second, didn't you add a 9? Shouldn't you subtract a 9 over here? Almost. This is not an exponent, I just am running out of room. This is a -9, so you have to add 9 to this. Okay, now that we did all the work, now I'm going to go and I'm going to simplify this. -3 to 1, -1. I've got 1 over. This is -x squared minus 6x minus 9. And then I would have +7 plus 9, and then this is where I'm going to get 16. I feel like I'm going to run out of room. I might have to take up some space down here and then fill it in later. It's okay. Oop, don't forget about the square root. Okay, if I take the square root and now I'm going to rearrange it into something that I know. I can see right now if I've got 1 over the square root of something, I'm looking and hopefully it's going to be either arcsine or arc cosine. This one's all positive so far, so I'm probably leaning towards arcsine. So I need something 1 minus u squared. Well, right now I've got a 16 here. So I'm going to say 16 minus this thing. How I can rewrite this, 16 minus, oh, I guess I could have even kept this as negative. This would be positive x squared, positive 6x, positive 9. If I factor out a negative, just that part. So 16 minus x plus 3 squared. And I've got 1 over. If I did this and I said, you know what, I want to divide by 16 or factor out a 16. See how I've got 16 times 1 minus, and then if I divide by 16 over here, I'm going to say x minus 3 over 16 squared. It's getting kind of little, so sorry. All of this is just manipulating with algebra. This then, I've got now square root of 16 is 4. And since it's multiplied, I can take apart the square root and I can be like, nope, square root of 16, square root of the rest of the stuff. And then I can bring it out in front. So all I'm going to have is a 1/4 out front. And over here then I've got a 1 minus. So I'm so close to what I want. This is going to be, instead of x minus 3 squared over 16, couldn't I rewrite it like that? And this is where I use pattern recognition again, and I'm not too concerned about the coefficients. I'm just thinking, okay, how do I possibly get to this? Like if I rewrote it and it all looks like this right now, I'm looking over here and I think, what has the antiderivative looks like this? Reverse sine. So I've got sine of x minus 3 over 4. And then if I think about what the derivative of the inside is, the derivative of the inside is going to be 1/4. And so if I'm going backwards, or I'm sorry, here, that's where, hold on, if I take the, I don't know why I have a dx. I need to start over on this page. Bye.